So now that we've talked about the reactive programming paradigm, let's spend a little time going through the Java Reactive Streams API. And you'll see what this is about. This is essentially an interface that was added, or a set of interfaces that was added to Java 9 that forms the basis for the reactive programming frameworks like RxJava and Project Reactor, which we will be going into in more detail. So here's a UML diagram that visualizes the various interfaces that are part of the Reactive Streams API. This API implements several patterns that you're hopefully familiar with from other stuff you've taken here at Vanderbilt. In particular, we're going to talk about the observer pattern and the iterator pattern and how they are combined to support this publisher-subscriber style interaction, which is also a pattern as well. And then we're going to talk about the key abstractions that are used when defining reactive programs. And this is kind of interesting because understanding these basic building blocks will help you understand the programming frameworks that encapsulate and embody these principles and abstractions very nicely. So starting with Java 9 and continuing on, there was support added to enable reactive streams via something called the Flow API. So the Flow API is a class Flow, and it's got a bunch of interfaces that are part of this class. And we also have support for stream-oriented pub-sub patterns enabled through the Flow API. So let's talk about that first. There are two major patterns that are defined here that are part of this, both of which appear in the Gang of Four book. Hopefully you've seen this book at the Intermediate Software Design course if you took that here at Vanderbilt. One pattern is the iterator pattern. And the iterator pattern applies a pull model where subscribers pull items from a publisher source. And what they really do is they come and say, I can take up to X amount of items in a tranche, in a chunk, and you, publisher or publishers, please send me that amount of data. So that's the iterator model where you're pulling things. And the second pattern is the observer pattern, which applies a push model that reacts when a publisher or a source pushes an item to one or more of the subscribers. So as you'll see, this publisher-subscriber-like model, which itself, again, is another pattern in its own right, is implemented using iterator plus observer. So hopefully you're familiar with those patterns. If you're not, you can take a look here at these links, or I have a whole slew of videos on my playlist somewhere that give descriptions of those patterns. The Flow API defines interfaces designed to ensure interoperability of reactive streams implementations. And these are the interfaces that are defined. So the Flow is a class, and nested in that class are four interfaces, basically publisher, subscriber, subscription, and processor. Now, the ironic part is when you program with the reactive programming frameworks like RxJava or Project Reactor, you very rarely see these things directly. Sometimes you see a little bit of it if you do certain things involving flow control, which we'll talk more about later. But in general, you don't really see these things. However, they are what's lurking under the hood. And in fact, it allows you to get interoperability between different reactive programming frameworks, such as RxJava and Project Reactor, because they all implement these basic interfaces deep in the bowels of the reactive frameworks. So let's talk about the abstractions that are defined here. And the abstractions map onto these different interfaces: subscriber, publisher, subscription, and so on. You'll notice, by the way, that the processor is going to extend both the subscriber and the publisher interface. So it basically serves as an intermediate node as data flows through a reactive stream. So a flow typically involves interactions between three key abstractions, and then you can combine the processor in intermediate stages along the way. So let's take a look at this. So we've got a publisher and a subscriber and a subscription. Without loss of generality, we could have multiple publishers, we could have multiple subscribers. I'm just going to focus on one at this point. Publishers are sources that produce 0 or more events. They can produce no events at all, they can produce one event, they can produce n events, they can produce n events where n is infinite, and so on. And these events are going to be pushed to subscribers based on the subscriber's subscriptions. And we'll talk more about that in a minute. Subscribers are sinks that register for and consume the events that the publishers push to them. So publishers push events and subscribers consume them. Of course, if a publisher never pushes anything, then the subscriber won't receive anything. And that's all part of the model. And we'll talk more about that in just a second. In fact, that communication process is captured, the semantics are captured in this regular expression, which says a publisher can push 0 or more events. That's what the onNext star means. 0 or more events can be pushed via the onNext hook method to one or more subscribers. And then optionally, it could be the case that there's an error that's reported. One error could be reported at the end of the 0 or more events. Or you could receive an onComplete event indicating that things are done. So those are the options. You can push 0 or more events, and then optionally, you might have an error to conclude the stream, or you might have an onComplete event which says I'm done successfully. Or you might never terminate, so in which case you wouldn't have neither on error nor onComplete. That's why those are optional. So that's a regular expression that describes how that works. There's another component or abstraction in this model called a subscription. And a subscription is used to control the flow of events between publishers and subscribers, or a publisher and a subscriber. And so what you can do when a subscriber registers with a publisher, it needs to tell the publisher how many events it can receive. And there's a couple of options. One thing it can do is it can give a value that's essentially infinite, like the max integer or the max long, in which case the publisher can send events as fast or as slow as it chooses, and the subscriber pledges to handle them all without having to worry about the subscriber's resources being overwhelmed by too many events from the publisher. So that's kind of the unbounded subscription model. Another model is where the subscriber can say, only send me up to n events, where n could be 1, 10, 100, 1,000, 1,000,000, whatever it wants to be, in which case that informs the publisher it can only send that many events by calling onNext, the onNext hook method on the subscriber, before it has to wait for the subscriber to say, okay, please send me the next chunk. And that is commonly known as flow control. And you can see this illustrated here where the subscriber tells the publisher, you can send me up to 3 events. So it says onNext, onNext, onNext. And then the subscriber has to say, okay, I want the next chunk of events. And then the publisher will send it those events. And there's lots of reasons for doing this. We'll talk about this in detail. The long and the short of it is you typically use flow control to avoid situations where a fast publisher overwhelms the memory and or processing resources of a slower consumer, slower subscriber. So here's how things work. Subscriber talk starts by saying, I want to subscribe to a publisher. And just like Java streams are lazy and nothing starts until you hit the terminal operation at the end, so too is a reactive stream lazy. And nothing does anything, nothing happens at all until a subscribe call is made on the publisher. So when subscribe is called, then the reactive stream becomes active. Up to that point, it's just snoozing away, not doing a thing. Very important to remember, because undoubtedly when you first start programming with reactive programming, you will forget to do a subscribe operation, and your program will just sit there, and you'll be like, why is it not working? That's probably why, because you have to subscribe. When a subscriber subscribes to a publisher, the publisher calls back on the subscriber using the onSubscribe hook method, and it passes it a subscription object. And that subscription object can then be used by the subscriber, or must be used by the subscriber, to say, this is how much data you can send me. And you can send either, like I said before, max value, which says just send it all as quickly as you possibly can, or n, where n might be a value like 3 or 10 or 1,000 or whatever. So this informs the publisher of the initial event demand. No events are sent by a publisher until the subscriber indicates the demand by calling this method. And sometimes this is done implicitly, but nothing starts until that happens. Once you're connected, once you've subscribed, once you've given the subscription, once the publisher knows it can start sending stuff, then it can begin the notification process of calling the onNext hook method to indicate to the subscriber there's something for it to do. And again, there could be 0 or more of these, and they form a stream. So you could start out, nothing could be sent, 1 could be sent, 10 could be sent. They're sent by calling onNext. Now again, you may or may not actually see this depending on the programming abstraction you use, but that's what's taking place under the hood. When everything finishes, if you have a stream that's a bounded stream and a publisher that reaches an end, then if all goes well, the publisher will call the onComplete hook method on the subscriber to indicate that it's sent all the events and now the stream is done for the time being. If you want to restart the stream, you have to resubscribe. This onComplete hook method is sort of metaphorically equivalent to the end of file character in Unix or Mac or Windows, where you have a stream of data coming from a file and you want to indicate you're done. So that would be the end of file. So it's sort of like that. However, not everything is unicorns and rainbows. So if something goes wrong, if the publisher reaches a point where it detects a failure of some kind, what it can do is it can pass the onError event up the stream, indicating what went wrong. And this throwable is basically a form of exception in Java. So this will be used to propagate an error from the publisher to the subscriber. And there's all kinds of ways you can address or you can register for and handle error events, which come in as exceptions. And we'll talk about those as we get more into the details of how to program with the reactive streams frameworks like Project Reactive. So those are the 3 ways you can communicate: onNext, onComplete, and onError. And that's the end of the quick overview of the Java Reactive Streams API. There's a lot more to this, but this is the basic building blocks that you have to understand in order to make sense of the paradigm.